Alright, today we're going to be focusing on graphing, which is another important part of the exam. We're mainly focusing on square root graphs, squared graphs, and reciprocal graphs. These are the three main graphs we're focusing on, and let's get started. First example, x minus 4 whole squared minus, this is minus 2x minus 5, x minus 4. And this is our f of x. Now, we see that x minus 4 is on both of these terms, so we can factor that out. Times x minus 4 minus 2x minus 5. And that is our function. We can simplify this, simplify the right bracket. X squared minus 4x minus 2x plus 5. And one more simplifying step. X squared minus 6x plus 5. And now we can factorize this to x minus 1, x minus 5. And that is our function. Now to graph this, I'll do this on this side. I'll make this line a bit straighter. Okay, so our first intercept is at 1, and then at 4, and then at 5. And we also need to find a y-intercept, so we let x equal 0. So y-intercept, we let x equal 0, minus 4 times minus 1 times minus 5. That is minus 20, and that is roughly here. So we start off. And that is our rough diagram here. And we know that it'll be going from downwards from this corner to the other corner, from the third quadrant here to the first quadrant. Since it is a positive, the leading term is positive, the leading coefficient in general. And we are done for this question. And we have to make sure that we also label the x and y, my bad, all the way around, x and y axis. So we go on to our next question. X squared plus 4 on x, and that is under an absolute value. Now for this question, it is a bit difficult. We need to think about this logically. Our main starting step would be splitting up this in the inside fraction into two fractions. We see that this had the same value inside. This expression just becomes x plus 4 on x. Now, if we were to look at this by splitting it up into these two graphs, you would get this. So this is our 4 on x graph, and then we have our other graph of y is equal to x. Now we are adding these two values. Now what we see is there's a horizontal asymptote at y is equal to 0. That's important for us to know, as our hyperbola graph approaches 0 as it goes to positive infinity and negative infinity. And our y is equal to x graph just stays the same as a linear line. So as the curve function approaches 0, its y value decreases and our y is equal to x graph stays the same. So if you look at y is equal to 1, we'll just find a pattern here. We look at, x is equal to 1, we find that is equal to 5, which is roughly here. We go to x equals 2, we get 4. This is not to scale, but try our best. And this one will go to 3, which is 3 plus 4 on 3, which is roughly, plug that in to make sure, 4 on 3, 1.33 plus 3, which is 4.33, roughly here. We go again. We'll say 4, 4 plus 1, 4 plus 4, which is 5. Plug that here. And you see that, and now we plug in 5, we'll get 4 on 5, 0, 0.8 plus 5, so that's 5.8, roughly here. Now, when you look at this pattern, we see that the general shape, if I draw this in another color, the general shape, sorry, this is wrong, general shape comes down and starts going up again. And this matches our observations. Now, mainly that as x is a very small number, if you look at it from this side of the origin, due to the 4 on x hyperbola graph, that small value of x will lead to a very big value in y. That's what we see in the hyperbola, and it's not really going to affect the linear graph because adding a small value is not going to change the y value as much. However, as you go positive, the hyperbola graph will approach 0, and the y is equal to x graph will take priority, meaning as our new graph approaches infinity, the 4 on x graph will approach 0, and our x graph will just approach our original x value. That's why the graph will approach our asymptote at y is equal to x. And our graph will look like this. And this will happen on the other side as well. Now, to figure out what this lowest value will be, to figure out the range of this function, we have to look at the fact that when you're finding the range, the lowest point, so if I draw these two graphs again, I'll just draw the first quadrant graph. Drawing this, the lowest point is going to be the point that they intersect at, which is at an x value of 2. And this x value of 2 will lead to a y value of positive 4, which is roughly here. And this is the point which our graph will reflect at, meaning our lowest point is 4, and that means the range has to be y is greater than or equal to 4. Now, normally, without the absolute values, our graph would be reflected like this, meaning this value would also be negative 4. And our range would be y is greater than or equal to 4, and y is less than or equal to negative 4. However, since we have an absolute value at the front, these negative values at the bottom are going to be reflected upwards. So these values will be like this. And this value will also be 4 because negative 4, the absolute value of negative 4 is just 4. Meaning our final range is just y is greater than or equal to 4. Or in interval notation, it will be open square bracket 4, infinity normal bracket. Now this is our range, and we will just write that here. It is important we write it in interval notation. That is very common in our exam. And our domain is just, if you look at this original function, x cannot equal to 0, meaning we have from negative infinity to 0, or 0 to positive infinity. And that is done. We'll go to our next question. We have graphing x squared times x minus 9. Now, let's graph x squared minus 9 actually. This graph, it can be simplified using difference of two squares. We'll say x squared times x minus 3, x plus 3. And we will start graphing. We have our intercepts using this form at 0, positive 3, and negative 3. Now we see that the leading term is also positive, leading coefficient. So this graph would come along like this. Wait, I think it's, oh, never mind. This is not a cubic graph, this is a quartic graph, meaning it will be positive and will bounce here, bounce at 0. Now it has x-intercept at 0, meaning its y-intercept is also 0, and this would be our graph done. Normally we would need to find the points of these as well, but that will come later this year actually. And that is done for this question. Now we look at y is equal to 1 on square root of x squared plus 6. This graph, mainly when there's a function within a function within a function, in this case this function x squared plus 6 is inside the square root graph, which is then reciprocated. You want to work backwards, drawing the inside function first and then working outwards. See that x squared plus 6, that's just the normal parabola, moved upwards by 6 units, so our y-intercept is 6, and this will continue on. Now we'll continue the red one, the next one in a bit a darker color. So we see that square rooting this graph is, since there's no x-intercepts and the function does not go below 0, it's not going to impact it as much other than just lowering the y values. A bit of a drastic change, but just to get the picture, the graph will be stretched and all the y values will be square rooted. Now we have to find the reciprocal of this function. Mainly this is done as we look at, oh sorry, this is actually incorrect. The new intercept would be square root of this over current intercept, which will be square root of 6, like this very function here. This y value would be square root of 6. That makes sense because you're square rooting each single value. Now we're going to be reciprocating this function, meaning our new value is going to be even lower. This point, this y value will be 1 on square root of 6. Now we start here and look at the general trend of the function. As x goes to infinity, y also goes to infinity. However, if we're going to be reciprocating this function as x goes to infinity, this bottom function will go to infinity, meaning 1 over infinity will approach 0. Up to 0, not infinity. So our new graph, if I draw this in green, for example, our new graph will slowly come down and have a horizontal asymptote at y is equal to 0. And has a y-intercept of 1 on square root of 6. And that will be our function. Now finding the domain and range of this function is very simple. For the range, we will see that it never reaches 0, so we start from 0 to 1 on square root of 6. And that is square brackets because it is included in the range. Now in the domain, you see that it can be all values. Yeah, it can be all values, yes. As the only reason this inside function will be negative is if we use complex numbers, which is not, we have not learned that yet. This x squared plus 6 can never be negative and also can never be 0, meaning our domain is all real x. Remember to put circle brackets around infinity signs. Our next function is a graph, and our question is to identify the square root, the square, and the square root, squared, and reciprocal of this graph. Now we start from a simple sketch over here. Now we see that if we draw this function, there's a horizontal asymptote at y is equal to 2 as the function goes from negative infinity up and then down to an asymptote. And what we have to know is, if we're going to be square rooting this graph, we have to first, now that we have a frame of reference for the original graph, we see that the x-intercept is at 0, and all of our vertical asymptotes and all of our vertical values in general are going to be square rooted. So before, since there was a y asymptote, horizontal asymptote at y is equal to 0, our new asymptote is going to be at square root of 0. And before, our max was at 4, now it's going to be at 2. So you draw the dotted line here and continue from here. Now our current x-intercept, that one stays the same, and our function will just go up and come down. And that is our square root function. However, this can also cause mistakes because this negative portion is going to be removed. That is very important. And if we were to find the domain of this function, we would say x is greater than 0. And the range is from 0 to, y 0 to 2. And that is our answer.
Done now.
Our next graph would be the reciprocal graph, where we have 1 over f of x. Now, if you look at our original graph, every y-intercept is also going to be reciprocated. So now that we had 2 before, now we'll have 1 on 2, and our max would be at 1 on 4. So this would actually be the other way around. Our max will become our min, and our asymptote will be at 1 on 2. And we see that as this approaches 0, which is our intercept, it will come from the top, approach at the same x value of 2. It will approach this point, and then come down here. Another thing to note, and from here it will also approach infinity like this. Another thing to note is that if we look at this from this point of view, currently we say that at x is equal to 2, the y value is 4. So that's our original function, and y is greater than our horizontal asymptote, which is 2. However, what we have to notice is that if you reciprocate a function, this inequality sign is also inverted, just like if you're subtracting or multiplying by a negative number. Now, if we were to do this, this would be 1 on y less than 2, or less than a half, sorry. And 1 on y, that's our new function. So we'll just name this f of x, or we'll name this g of x actually, it's our new function. And this can be seen in our graph, where this point is less than 1 on 2. Now that's what you have to notice. As you flip the graph, all the y values are also flipped. And that means the range is also going to be inverted in this case, for example, where the horizontal asymptote, the new values are going to be, before they were above the asymptote, now they're going to be below. And they're going to approach it from a different side. In our old graph, the horizontal asymptote, it's approaching from the positive side, so it's going to go from 2.1, 2.001, 2.0001, and approach 2 from there. From our new graph, it's going to approach the reciprocal of that, but from the negative direction. So it's going to approach 2.5 through 0.4, 0.45, 0.459999, and approach 2 in that direction. This is very important, as we want to make sure our function, I'll draw this in red to make sure, function does not go down like this. This would be wrong, as our new function has to go below the asymptote, as what we have proved here. And our final function would be, I have not done the domain of this. The domain of this very function would be x is all real, subset of all real values. However, x cannot equal to 0. And our range, we will say our minimum value that we calculated here was a quarter. So we will say it is from negative infinity to 0. It can't approach 0 because there's an asymptote there. And it can be square bracket to positive infinity. And that is our range. Now, last part of this question, we will do f of x whole squared. We will draw the function, draw the axis, Now all these y values are going to be squared, as well as all the horizontal asymptotes. So before the horizontal asymptote was at 2, now it will be at 4. And our max y value was at 4, now it will be at 16. Drawing this not exactly to scale, just for educational purposes. Now we have to know that all the negative values will also be squared. So this graph would be going upwards like this, and our new squared values would approach like this. And that is our function. Now the domain of this is the same, where x is a subset of all real values. Just making sure that that's actually true. Yes, that looks like it. However, our range does change. It goes from y is greater than or equal to 0. Or we can say this. Oh, sorry, got cut out. We can say this. And same for this case. And this was our last section. So we'll move on to the next question. We have y squared equals x cubed minus 4x. Now, similarly to last question, we will have to graph the original function and continue from there. Now, factorizing this, we get x squared minus 4, which is equal to x times x minus 2 and x plus 2. Can't really fit it there. So we get 0, x equals 2, and x is equal to negative 2. Now, we have to graph this. We know it's a cubic to the power of 3. And let's continue. I'll actually draw this in a lighter color because we have to draw over it eventually. Now, notice that this is an odd function, meaning both sides of the y-axis will be the same. This should actually be negative 2, and this will be 2. Now, we go to square root this function. Now this will be a plus minus square root, so y is equal to plus minus square root of x cubed minus 4x. Now we look at this value. This is a single root, meaning it will be reflected. We have to make sure that every time that you have a graph, the square root of that graph will be greater. The y value will be greater if between all the y values of 0 and 1. So what I normally do is draw a line on y is equal to 1. And all the values that are below it would be greater than this value. So normally if you think square roots, we would say that the value is lower. For example, square root of 9 is 3, square root of 4 is 2, square root of 25 is 5. But if you look at numbers that are less than 1, it's actually the opposite. If you look at the square root of a half, we look at the square root of 1 over 4, we get 1 over 2, which is this y value actually reduces due to the fact that it's got square rooted. The y value actually increases now that it got square rooted. Not very intuitive, but that's just how it is. So we start off here, and it'll be like this, where our single root turns into a square root. If we look at a square root function, this type of around this intercept, that's what it will look like. And all these values will also be shrunk, all these values will be greater up until this y value. So it'll be greater, and until there it will be smaller, and then when it comes back down it will be greater again. And that is our square root function. If I draw this in red to make it a bit more clearer, that will be our function. But we are not done yet. Now we notice that we had to make a plus minus. So this graph will be repeated along the x-axis. And that's our function. Now our next question is very similar to the one that we just did, which is y squared equals x to the power of 5 minus x to the power of 2. This should actually be 4. So you will continue, draw this graph, and we will use a darker color. So we should start off by factorizing first. X squared times x squared minus 4 simplifies to x squared let's just start a new line. X squared, x minus 2, x plus 2. Okay, now we continue. We will graph the original function first in gray, starting at 0, 2, and minus 2. And we'll see that this is a double root and it's a quartic, so the graph would come here, bounce, and go back up. Okay, now square rooting this graph is actually much easier than our previous graph, where however there is one trick, there's one thing we need to be wary of, which is this point right here. Now this point, let's just ignore this for now and focus on the rest of the graph. We'll come back to it just a second. This is this root is a single root, and it will just look like this would be square rooted. So in the y value of 1, this would be greater. So it would come up and then come down. Same thing here, it would come up and then come down, looking like a square root function. However, this point right here, this is important. When you're square rooting a function, only the positive square root values, positive or 0 square root values can actually be applicable. Where only the function that is above 0 or equal to 0, that's where the function is actually there. Other than that, this part below and this part below are not there anymore. And that is what we have to notice in this point here. This is a single point that makes the y value 0, and that is able to be square rooted. So the way we have to note here, this is a point that will exist in our function only one point, where at this point it will be non-continuous. That's what we have to make sure of. So our final function would look like this. So this would be a point of 0, and then 2, and negative 2. This point of 0 is very important and could be the difference between many marks in the exam. So our final function will just be plus minus square root of x squared, x minus 2, x plus 2. And now we have to make sure that since we are doing a plus minus, this would also be this would also be reflected across the x-axis. And that is our function. And now we'll go to our last question, which is f of x equals 1 over x cubed minus 2x squared minus 8x. Now, factorizing this function, 1 over x minus 2, x squared minus 2, x squared minus 2x minus 8. This can also be further simplified, x times x plus 2, x minus 4. And this is just a simple reciprocal graph, where we will start the original graph in gray. We have the x value of 0, negative 2, and positive 4. Graphing this function, you will get something like this. Now, taking the reciprocal of this, we know that there's a vertical asymptote at negative 2, 0, and 4. In the exam, even though that x equals 0 is on the y-axis, we want to make sure that we put a vertical asymptote there, just to make sure to avoid losing any marks. It is very sad when you lose a mark like this. And we would continue on. Our reciprocal graph would follow a general shape like this. And this is our function. The general shape indeed. And later on, we will actually learn how to calculate these values, where we have the stationary points using differentiation, which is very interesting. And that's our function right there. And we should also make sure to put down these arrows to indicate that the x-axis and y-axis are both continuous. And yet, if we were to find the domain of this function, this would be from negative infinity to, actually no, that is incorrect. This would be from negative infinity to 2, intersection, union, yes, that means or, and from 2 to 0, union to 0 to 4, and 4 to infinity. And I think that is the end. Actually, no, we have one more function. We would say y is equal to absolute value of x minus 1, minus x plus x minus 2. Now, this graph, when we are graphing multiple absolute values, we should have to take cases. Case 1, where x, first, actually, we should slow down, we should take a look at the critical points, which are 1 and 2. So we will say these will be our three cases. X is less than 1, 1 is less than equal to x, less than equal to 2, and x is greater than 2. We'll start off with x is less than 1, which will make this function negative. So we'll say negative x plus 1, negative. This function would also be less than 1, so it makes positive x minus 2, and that is our function. That's equal to y. Y should really go at the front. This x and this x cancels out, and we have y is equal to negative 1. So in our domain, this is important, in our domain of y is equal to x is less than 1, our equation is y is equal to negative 1. Negative 1. And let's continue. We have our next case is like this, and this domain will make our first absolute value positive. This absolute value would disappear. Minus our second absolute value would be negative as well. So we'll do this, and that is again equal to y. So y is equal to 2x minus 3, and we will graph this. So we'll get the y value roughly, this would be 3, and 2x would be like this. Just sort of, however, we are actually looking at this function will be in the domain of y is less than 2. So if you plug in 2 into this function, we will get 2 times 2, which is 4, 4 minus 3, which is 1. Oh, my bad. This actually is minus 3. And that means, if you look at this function, y is equal to 2x minus 3. I feel like I did something wrong here. Oh, sorry, my mistake. We have this, our first domain was, this first function was actually wrong. It would have been past the y-axis at the x value of 0, so we negative 1, and from here, this is a y value of 1, and our next function is a y value of 2. And this is where the function changes, where we have, this is minus 1, this is minus 2, minus 3, and this is where our graph changes, where this would be like this, where our new function will end at y is equal to 2. Our new function, this new function that we just made, will end at x is equal to 2. And plugging in x is equal to 2, we would get, this should actually be 1, not 2. We would get y is equal to 2x minus 3. And plugging in 2 into our function, we would get 4 minus 3, which is 1. Now, on to our last domain, we would get x is greater than 2, and plugging that into our function, we would get x minus 1 minus, and plugging in a number greater than 2 will make our second inequality always positive, so we don't have to change anything for that one, and that is equal to y. Okay, y is equal to this x, and this x cancels out. We would get minus 1 plus 3, which is equal to 2. So our new function is y is equal to 2. Meaning, sorry, this should actually be, sorry, this, yeah, okay, to make sure I add correctly, this one would be plus 2, and that is equal to 1. Yes, so our new value, when x greater than 2, we would get y is equal to 1. And this is our function. Making sure we have to put these n values and indicate this is the x and y axis. And this is our final question. Thank you for watching.